Hello students, today we are going to discuss digital signal processing. In this subject, digital signal processing, one of the important chapter is convolution. So definitely if you will found in university examination, one definitely question you will get from this chapter, that is your convolution sum. Uh, as far as in signal system is also is concerned, also convolution sum is there. So what is convolution in signal system or in digital signal processing? So if there is a system, this is a system. Suppose there is an input here, this is your input and this is your output and this is your system. Okay. If I will say there is a system, this is your input is let that is your x of n and output is this is your y of n in a discrete signal x of n and y of n, x of n, y of n are discrete signals. So system by means of transformation. Okay. So y of n I can say, so transformation of x of n. What does it mean? If you are giving the signal x of n to the system by means of transformation, you will get the y of n. What is the physical significance of the convolution? So convolution y of n, if there is a system, there must be a transfer function, and h of n, if h of n is a transfer function and y of n is nothing but what, that is your x of n by means of convolution, x of n convolution of h of n. This symbol represents the convolution. If you are giving the input to a system, output by nothing but what, the convolution of x of n with h of n, and transformation of x of n is nothing but y of n, that is x of n convolution of y h of n. X of n convolution of h of n is nothing but y of n. And any signal and system in a discrete system, if there is an input and there is an output, and in system having some transfer function h of n, and output can be obtained by means of the convolution x of n convolution of h of n. Suppose any x of n, any arbitrary sequence x of n can be represented by means of sum of weighted sum of delayed impulse signals. Impulse signal I am already that is impulse signal is nothing but del of n. That is your impulse sequence. I can say del of n. So if x of n equal to del of n, if I'll say by the input x of n is your del of n and output, if there is a system by means of transformation, and output y of n, this is nothing but your transformation of what, that is your del of n. Okay. So then in x of n can be represented in terms of impulse sequences, sum of weighted impulse sequences. That's why I can say, right, if there is a system by means of transformation, x of n can be represented by means of what, sum of, that is your k equal to minus infinite to infinite, that is your x of k into del of n minus k. So any arbitrary sequence, discrete sequence x of n can be represented by means of weighted sum of the delayed sum of the impulses, and this is a system, and y of n is nothing but your what, the output of the system. This is your system by means of transformation. So y of n equal to transformation of x of n, and x of n is nothing but transformation of, that is your x of k into del of n minus k, and it can be represented as x of k into transformation of del of n minus k. So transformation of del of n minus k is nothing but what, that is your h of n comma k. It is very important for a linear time invariant system. For a linear time invariant system, suppose there is a linear time invariant system, LTI system. In a linear time invariant system, if there is an input and this is your output, input is your x of n and output is your y of n, for as far as shifting property and their stability is concerned, for linear time shift variant or time invariant, h of nk equal to h of n minus k. H of n comma k, that is your h of n minus k for linear time invariant system. So by means here x of k into h of n minus k, and h of n comma k is nothing but what? That is your x of k into h of n minus k. This is all about your what? And here already that is your k equal to minus infinite to infinite. K equal to minus infinite to infinite. Equal to k equal to minus infinite to infinite. So what we have observed, suppose in a linear time invariant system, if there is an input and there must be an output, output is nothing but the convolution sum of the part x of n into h of n. X of n can be represented for a linear time invariant system. X of n can be represented in terms of delayed or scaled unit impulses x of k into del of n minus k. If x of n represent in terms of unit impulse sequences, by transformation of this, you will get y of n. How to get y of n? Output can be represented in terms of convolution. That's your what? Y of n equal to, that is your this x of n, that is your x of k into h of n minus k, that is your k equal to minus infinite to infinite. So this is all about your what? That is your y of n. So here what we have observed in convolution sum, convolution sum, y of n equal to x of n convolution of h of n, and the mathematical formula is what? That is your k equal to minus infinite to infinite, that is your x of k into h of n minus k. This is very important, and there is a mathematical formula how to get the convolution of the two discrete sequences. If x of n and h of n is given, how to get the convolution of x of n, convolution of h of n, and there is a procedure. What are the procedure? What are the steps? The steps how to carry it out the convolution of two discrete signal x of n and h of n is given. If x of n is given and h of n is given, how to get the y of n? That is our motto, or that is our aim, to get y of n, that is your convolution of x of n with h of n. Simply x of n simply converted, that is your x of k, and h of n is nothing but your h of k. Then what we'll do? Step 1, that is your what? Step 1, that is your folding. Folding, folding. Fold h of k about k equal to 0. That is your, in folding, that is your what? H of k is nothing but h of minus k about k equal to 0. That is your folding. Then step 2, that is your shifting. Folding, then shifting. Then how to shift h of minus k? Your original x of k is constant. Folding, first step is your h of minus k. Second sequence, h of n to h of k, then folding h of minus k about k equal to 0, that is becomes h of minus k. Then this folding sequence you can shifting. You will shift either right or left, either delay or either forward, delay or advance. For n equal to successive value of 0, 1, 2 and minus 1, minus 2, like this, you will get h of minus k, h of minus k minus 1, h of minus k plus 1, h of minus k plus 2, h of minus k minus 2, like this. In this way, you can shift the sequence up to what? That is important. I will tell you later. Then after folding, then shifting for successive value of n, for different values of n, for different values of n, for different values of n, you will shifting. Then step 3, multiplying. But multiplying x of k with h of minus k, first one, for k equal to 0, for k equal to 1, for k equal to 0, successive sequence for k equal to 0, so let that is your x of k multiply with h of minus k for k equal to 0. Similarly, if I'll say k equal to 1, that is your what? X of k convolution of what? H of minus k plus 1. Multiplying this, you will get y equal to 0, y equal to 1. In this way you can find out. For k equal to 2, that is your x of k, convolution of what? Multiply with what? Multiply with h of minus k plus 2, like this. If I'll say k equal to minus 2, that is your x of k into h of minus k minus 2. In successive values of n, you have multiplied x of k into h of minus k, corresponding value of y of 0, y of 1, y of 2, y of minus 1, y of minus 2, like this. In this way, you can find out the convolution of particular discrete values of n. Now, for a example, suppose I can say find the convolution, find the convolution of two discrete sequences, two discrete sequences, x of n given, x of n given, that is your 1, 2, 1, 1. H of n given, h of n given, that is your 1, 1. Okay. Okay. So x of n, h of n given, find the convolution to this sequence means we have to find out the y of n. To find what? To find y of n. It is very, very important. Once your fundamental will be clear, then you will do any type of problems related to convolutions. So this is your questions, x of n given, h of n given, to find the y of n. Solution. In this example, I will give you the details regarding how to find out the convolution y of n, that is your x of n convolution of h of n. First step 1, x of n is given. Here x of n, that is your x of k, that is your 1, 2, 1, 1, that is your 1, 2, 1, 1. Origin mark is here like this. That is your what? If you need a graphical representation, this is your 0, 1, 2, minus 1, and this is your minus 2. In this arrow mark indicate at 0, n equal to 0 here, n equal to 0, that is your 2, this is your 2, n equal to 1, that is 1, this is your 1, this is your 1, and this is your also 1. Okay, x of k. And h of k, here h of k, that is your 1, 1. If here the arrow mark does not mention here, very fast bit is nothing but your n equal to 0 here. That's why that is your 1, this is 1, 1. In graphical representation here, for n equal to 0, this arrow mark indicate n equal to 0, that is your here 1, and n equal to 1 also 1, 1 also 1. This is your x of k and h of k. Step 1, starting point of y of n, starting point of y of n. Y of n is nothing but what? Y of n equal to x of n convolution of h of n, that is your sigma minus k to k equal to minus infinite to infinite, k equal to minus infinite to infinite, x of k into h of n minus k. Okay. How to get y of n? First step 1 is starting point of y of n. We are successively shifting the second sequence h of n for what values? This is the starting value. Starting point of y of n, there is your formula is your xn plus hn. The starting point of x of n, here what? That is your n equal here, n equal to 0. Here this value is your n equal to minus 1. Here this your n equal to 1, this your n equal to 2. That this arrow mark does not mention here means very fast bit is your n equal to 0. So x sub n starting point is your what? N equal to -1. Remember, this arrow mark indicate n equal to 0 and this is your starting point n equal to -1. That's why xn equal to -1 plus hn. Starting point of h of n is your n equal to 0, -1 plus 0, that is your -1. So starting point of y of n, that is your -1. Then right extreme of y of n. This y of n is your final output, that is your x of n convolution h of n. The final output, the length will be how much? The starting value will be from -1 and ending value must be what? Here the ending value, right extreme what? n equal to 0, n equal to 1, n equal to 2. Right extreme of x of n is the xr plus hr. Right extreme of xr, first sequence is your what? 0, 1, 2, that is your 2. Right extreme of hr, that is your here 0, this is your 1, this is your 1, that is your 3. This is very, very important. This is your basic things. First of all, when you are going to find out the convolution of the two discrete sequences, first of all, step 1 to calculate the what will be the length of y of n, what is the starting value, what is the ending value. The starting value of y of n, the starting point of x of n, that is your -1, and starting point of h of n, that is your 0, -1, and right extreme of this your 0, 1, 2, and right extreme of h of n, that is your 1, 2 plus 1, 3. Therefore, n equal to, that is your -1, 2, 3. It is very, very important. First of all, you have sure that is your what? Your original, your final output having length -1 to 3. -1 to 3 means obviously -1, 0, 1, 2, 3. Your length will be 5 number of bits. Do you understand or not? That is your y of -1, y of 0, y of 2, y of 3. Now y of n, so or already or another formula is what? Length of y of n, length of y of n equal to L plus m minus 1. L is nothing but the length of x of n. The length of x of n, that is your what? 1, 2, 3, 4. That is your 4. Irrespective, that is your 4. Length of h of n, that is your 2. Minus 1. That is your 6 minus 1, that is your 5. Obviously 5. And already n equal to what? -1, 0, 1, -1, 0, 1, 2, 3. That is also 5 or not? So that means 5 values of y of n we have to calculate. This is the basic things. First of all, when you are going to find out the convolution of the two discrete sequences, first of all, find out the starting point and ending point of y of n. Then what we'll do? We will start -1 for k value, successive value, k equal to, this is your what? Our n equal to -1, 2, 3. N equal to -1 to 3 means what? First of all, when k equal to -1, x of k is nothing but what? In x of k equal to 1 to 1, 1. First of all, x of k equal to 1, 2, 1, 1. Origin is here right, like this. H of k, that is your what? That is your 1, 1. This origin is like this. Here, this is your 0, 1, 2. In 0, that is 2. 1, 1. Also 1. This is your x of k. H of k, this is your 1, and also this is 1. 0, this is 1. This is your h of k. Then folding h of minus k about k equal to 0. In folding, whatever 0, that will be same. In 0, whatever the 0, that will be same. This is 1. Whatever 1 becomes to -1. Changes 1 to -1. 2 to -2, -2 to 0, like this. Folding, whatever right side goes to the left side, whatever the left side goes to the right side. They are folding. H of minus k what? 0 is 1, here is constant, and 1 is like this. This is your 1, -1. This is all about your what? H of minus k. Okay? h of minus k, h of minus k is like this. H of minus k is what? This is your what? This is your h of minus k. This is your h of minus k. Okay. For k equal to minus 1, then folding. After folding, step 2, that is your shifting. For shifting, we have to find out y of minus 1. Y of minus 1 means what? K equal to minus 1, y of minus 1. H of, first of all, we have to find out for n equal to minus 1, h of minus k minus 1. X of k is fixed. H of minus k minus 1. Minus k minus 1 means your sequences shifted to left by 1 unit. That's why like this. This is your 0 at 0. This is 1. This is your whatever minus 1 shifted to the left by 1 unit here. Like this. 0, whatever the value of 0, this is your minus 1. Whatever position are 0, these impulses shifted to the left by 1 unit. Whatever this are position number minus 1 here, minus 1 here. Whatever minus 1 go to the left, minus 2 like this. This is your what? H of minus k minus 1. Remember, first of all x of k, then h of k is like this. Then folding, this is your folding. This is your folding, fold. In folding h of minus k, then shifting for k equal to minus 1. For k equal to minus 1, h of minus k minus 1. By if it is minus 1, shifted to each sample sequence shifted to the left by 1 unit. Whatever 0 goes to minus 1, whatever minus 1 goes to minus 2. This is your h of minus k minus 1. And here h of minus k minus 1 is like this. In sequential representation, in 0, this is your 0, this is your 1, this is your 1. This is your h of minus k minus 1. Then y of 1, y of minus 1 equal to x of k into h of minus k minus 1. Multiply simply what? Look at this here. At n equal to 0, multiply this with this. At n equal to 0, 2. N equal to 0, 0. 2 into 0, that is your 0. Plus minus 1, 1. Minus 1, 1. 1 into 1, that is 1 here. In right side, whatever the value, that will be 0. That is your 0. Only at n equal to 0, 2, n equal to 0, 0, 0 into 2, 0. Then minus 1, 1. 1 into minus 1, 1. 1 into 1, 1. 0 plus 1, 1. That is your 1 here. So therefore, y of minus 1, that is your 1. Okay, very interesting. Then for n equal to, our sequence must be what? Our sequence must be minus 1 to 0. That is your minus 1, again 0, then 1, then 2, then 3. Up to this sequence. First minus 1 is over, then come to 0. Minus 1, then come to 0. For n equal to 0. For n equal to 0. For n equal to 0, only x of k, h of minus k, x of k, only h of minus k. H of minus k is nothing but what? H of minus k, that is your 1, 1. This is your h of minus k. Nothing will be worry. This is your h of minus k. So then x of k into h of minus k, simply multiply x of k with h of minus k. X of k this. X of k with h of minus k, n equal to 0, 1, 0, 2, 2 into 1, 2, plus, then what? N equal to minus 1, 1, n equal to minus 1, 1, 1 into 1, 1, that is your 1, 2 plus 1, that is your 3, and nothing will be find out because, and irrespective of 0 and 1, you will get all values are 0. Here n equal to 1, 1, n equal to 1, 1, here n equal to 1, nothing is there, means 0, 1 to 0, 0, 1 to 0, 0. Only you will get this sequence 2 into 1, 2, 1 into 1, 1, 2 plus 1, that is your 3. For n equal to 1, y of 0, you will get here, that is your 3. Same thing for n equal to 1. For n equal to plus 1. N equal to plus 1. Remember, your sequence is your h of minus k. After folding, then shifting. After folding, then shifting. H of minus k, minus 1, h of minus k plus 0, that is same h of minus k, then h of minus k plus 1. We have to find out h of minus k plus 1. Your original sequence from folding, you have to shifting. H of minus k plus 1. H of minus k is like this. Plus 1 means what? Plus 1 means shifted by 1 unit to the right by 1 sample. H of minus k plus 1. Here, whatever minus 1 becomes to 0 because to the each sample sequence, each sample shifted to the right by 1 unit. Whatever minus 1 goes to 0 here. This is your here and this is your here, 0, 1. Whatever 0 comes to 1. This is all about your h of minus k plus 1. And the value is what? The value is 1. Multiplying what? H of minus k plus 1 is nothing but what? H of minus k plus 1. That is your 1, 1. Like this. H of minus k plus 1. And you have to find out x of k into h of minus k plus 1. And it is nothing but what? That is your y of 1. The value will be how much here? Multiply this x of k into h of minus k plus 1. Sorry. Okay. And here n equal to 0, that is 1, 1 equal to 1. Multiply this with this h of minus k plus 1. N equal to 0, 2. 2 into 1, that is your 2. Plus n equal to 1, 1. N equal to 1, 1. 1 plus 1, 1 into 1, 1. Like this, that is your 3. So, therefore, y of 1 equal to 3. Okay, then come to, that is your n equal to 2. For n equal to 2. For n equal to 2. That is your what? H of minus k plus 2. H of minus k plus 2. Look at this here. Here minus k plus 1. Minus k plus 2 means each sample unit shifted to the right by 2 unit. Or minus k plus 1 means each shifted sequence shifted by right to the 1 unit. Whatever this, you will get h of minus k plus 2. 0, whatever the 0, that goes to one position number 1 here. Okay. So h of minus k plus 2, h of minus k plus 2 is what? That is your here, there is no value here, and that is your 1, 1. H of minus k plus 2. Then find out that is your y of 2 equal to x of k into h of minus k plus 2. The value is how much? Look at this here. Multiplying this with this. N equal to 0, that is your 0. 2. 2 into 0, that is your 0. N equal to 1. 1 into 1, 1. 1 into 1, 1. So that is your 1 plus 1, that is your 2. Therefore, y of 2 equal to 2. Then come to n equal to 3. Final step, n equal to 3. For n equal to 3, I am distinguished this color because it will be y of 3 for n equal to 3. For y of 3, we have to find out that is your h of minus k plus 3. H of minus k plus 3. This is your here. This is all about your h of minus k plus 2. Again, this sequence shifted to the right by 1 unit. H of minus k plus 2 shifted to right by 1 unit, or h of minus k shifted to the right by 3 units to get h of minus k plus 3. So h of minus k plus 3 is like this. Here, h of minus k plus 3 here. Whatever here 0, that is your 0, 1, 2, 3. Whatever this goes to 2, that your sequence existed at this and this. This is your 1 and this is your 1. This is your h of minus k plus 3. Multiply this with this. H of minus k plus 3 in sequence representation, that is your 0, this is your 0, 1, 0, and that is your 2, 1, and this is your 1. This is your h of minus k plus 3. This is your h of minus k plus 3. Okay. If you multiply this and this, x of k with h of minus k plus 3, at n equal to 0, 2, n equal to 0, 0, 2 into 0, that is your 0, 1 into 0, that is your 0, then n equal to 0, 1, 2, 0, 1, 2, in 2, that is your 1, that is your 1 into 1, that is 1, and you will get that is your 0 plus 1, that is 1. Therefore, y of 3 equal to what? 1. Our sequence y of minus 1, that is 1, that is your 3, that is your 3, that is your 1, 3, 3, and this is your 2, and this is also 1. This is our final values of y of n, that is your y of n. We have got, first of all, that is your 1, and second one is your what? That is your y of n equal to what? Sequence starting from minus 3 to, that is your 1, the minus y of, that is your n equal to, starting point n equal to minus 1. That's why y of minus 1, y of 0, y of 1, y of 2, and y of 3. Okay. So y of minus 1, that is 1, y of 0, that is 3, and y of 1 also 3, y of 1 also 3, y of 2, here y of 2 is how much? Y of 2, 2, y of 3, 1. This is your 2, and this is your 1. This is your answer, final answer, that is your y of n. This is nothing but your what? X of k convolution of, that is your x of n convolution of, that is your h of n. So x of n convolution of h of n equal to, that is your y of n. The final answer is like this. We have to check whether our answer is really right or wrong. First of all, x of n is your what? Was sequence was what? 1, 2, 1, 1. And h of n was what? This is your x of n. And h of n, this is your x of n. This is your x of n. And h of n was what? That is your 1 and 1. Sorry. Slightly we have to carefully do this. X of n, to check x of n is your what? That is your 1, 2, 1, 1. And h of n is your what? 1, 1. Then what you will do? That is your 1, 1. This is your x of n, and this is your h of n. Okay. So 1 into 1, that is 1. 1 into 2, that is your 2. 1 into 1, that is your 1. 1 into 1, that is your 1. 1 into 1 also 1. 1 into 2, 2. 1 into 1, 1. 1 into 1, 1. Okay. So this is your x of n, and this is your h of n. Okay. Okay. So in this, you have to find out like this. Okay. So first one, this is your 1, already there or not? Second, 1 plus 2, 1 plus 2, that is 3. 2 plus 1, that is 3. 1 plus 1, that is 2, and this is 1. This is a shortcut method. Whether your answer is right or wrong, you will, in this method, you can check it whether your answer is right or wrong. Okay. And here, this is your x of n, 1 to 1, 1. Whatever this, that is your h of n, that is 1, 1. Simply multiply this value, 1 into 1, 1. 1 into 2, 2. 1 into 1, 1. 1 into 1, 1. 1 into 1, 1. 1 into 2. 1 into 1, 1. 1 into 1. Okay. And then diagonally you like this. And then here first 1. Second 1 plus 2, that is 3. 1 plus 2, that is 3. 1 plus 1, that is 2. And this is 1. And you will get this value and this, you're absolutely right. That's why whatever result you will get almost right. In this way, you can check it, your output will be right or wrong. In this way, this is all about your convolution of the two sequences. This is a very good example to find out how to find out the discrete convolution sum of two discrete signal is given, that is your x of n and h of n. If x of n, h of n is given, then converted x of k and h of k. If y of n is the convolution of x of n and h of n, and this mathematical formula or empirical formula to find out the convolution sum x of k into h of n minus k, how to get this value in graphical representation, and we'll do the x of k and h of minus k. First, in step 1, you have to confirm or you have to sure whether your starting point of y of n. The starting point of y of n is your starting point of x of n with starting point of h of n. Here the starting here what? -1. Or this arrow mark indicate n equal to 0 and this is -1. And starting point of x of n, that is your -1, and starting point of h of n, that is your 0, -1 plus 0, that is -1. Then right extreme or end point of x of n, that is your 0, 1, 2, this is your 2, and end point of h of n, that is your 0 and 1, 2 plus 1, 3. Then you make sure that your starting point, your final your target output y of n, the length of output y of n is your what? Varies from -1 to 3, and total number of sequence, that is total number of shifting, -1, 0, 1, 2, 3, 5. The 5 values of n you have to perform. So that's why the length of y of n equal to L plus m minus 1. L is your capital L is your length of x of n. Capital M is your length of h of n, that is your 4. This is your 2, 4 plus 2, 6 minus 1, that is your 5. This is all about your preliminary things when we are going to perform the convolution sum of two discrete sequence. Then what we'll do? The step 1 here, that is what? That is your this is your basic things. Then first of all folding. This is your x of n. This is your folding, and this is your folding. To fold what? H of k becomes h of minus k. X of k is given. H of k is 1, 1. If you fold at about k equal to 0, that becomes h of minus k. Whatever at n equal to 1, 2, 3 becomes n equal to -2, -2, -3. Whatever -1, -2, -3 becomes to n equal to 1, 2, 3 like this. So this is h of k becomes h of minus k. Whatever this n equal to 1 goes to n equal to -1. And in graphical representation, h of minus k is like this. And then minus k minus 1. Your starting point for n equal to -1. That's why n equal to -1 means from original position is your h of minus k. From this, you have to shift n equal to -1 means h of minus k minus 1. And whatever the value of h of minus k, if minus k minus means that is your advance. Minus k minus 1 means the sequence shifted to the left by 1 unit. Whatever minus k is each sequence, each sample shifted to the left by 1 unit. Whatever 0 becomes to -1. Whatever -1 goes to -2. Here h of minus k minus 1. This is a graphical representation. In sequence representation, that is your 1, 1, 0. This is 1, 1, 0, h of minus k minus 0. Then multiply x of k with h of minus k minus 0. Whatever 0, 0, 2 into 0, 0, 1 minus 1, that is 1, minus 1, 1, 1 into 1, 1. So h of y of minus 1 equal to 0 plus 1, 1. In this way, you can find out n equal to -3, minus 1, 0, 1, 2, 3. In this way, finally, you'll get y of n like this. To check whether your answer is right or wrong, using this method by shortcut method, and here x of n 1 to 1, 1, here h of n, and this your h of n, and this your x of n, multiplying this 1, 1, 1, 2, 1, 1, 1, 1, then 1, 1, 1, 2, 1, 1, 1, like this. You will get 1, 2 plus 1, 3, 2 plus 1, 3, 1 plus 1, 2, 1, like this. And your answer is matched with this answer. That's why your whatever you will get the output, that will be right. Thank you, students. Next class we will do more and more number of problems related to convolution sum. Thank you.